So welcome again. So this is the next video of ATU Advanced Manufacturing Technology question paper solutions. So the question is from May 2019 question paper. Question is 1B. What are the advantages of powder metallurgy? Okay. So what are the advantages of powder metallurgy? And here the marks, 4 marks. So I will share the answer. Okay, so first of all, what is powder metallurgy? Just a simple definition. Powder metallurgy, fine powdered materials are blended, pressed into desired shape in a die, and heated in a controlled environment to develop bonding between contacting surfaces of particles and hence to obtain the desired properties. First, prepare the powder, then press this powder into desired shape, then heated, that is called a sintering in a controlled environment, and you will get the final product. You can develop tiny products as small as tiny balls of ballpoint pens. Also, you can develop parts weighing up to 50 kilograms can made by this process. Then various powder production methods are atomization. Then in atomization, there are various methods. I already explained what is atomization. Gas atomization, then water atomization, centrifugal atomization, two types, rotating disk method and rotating electrode process method. Then liquid gas atomization, electrolysis, reduction of oxides, reduction of carbonyls. Then the various operations in powder metallurgy are, first one is the blending and mixing. So that means mixing of the powder and also some lubricants, binders, etc. That is called blending and mixing. Then powder compaction. Powder compaction means pressing in this die, that is a uniaxial pressing. That is called a powder compaction or pressing. So after pressing, you will get the desired shape, but there is no strength. Only the shape. You will get the desired shape, but there is no strength. Then after that, see, there are various types of pressing methods are there. That is isostatic pressing. One method is CIP, called isostatic pressing. So this is carried out at room temperature. So what is isostatic pressing means? Uniform compaction, ensure more uniform compaction with other uniaxial pressing processes. So previously explained, that is the uniaxial. The uniaxial means only one axis, uniaxial pressing process. So in isostatic pressing, uniform compaction compared with the other uniaxial pressing process. So one method is CIP. This is carried out at room temperature. That is called a cold isostatic pressing. Then next is the HIP. That is called hot isostatic pressing. This is carried out at a higher temperature. Pressure of 100 megapascal at 1100 degrees Celsius is a commonly used condition for HIP, that is hot isostatic pressing. Then next is the sintering. Sintering means the thermal treatment. Thermal treatment of the powder compact at a temperature below the melting point of the material for the purpose of increasing its strength by bonding the particles together. And the main parameters are the sintering temperature, sintering time, and sintering atmosphere. Then the various mechanisms of sintering are the diffusion and mass transport between. This is an example of showing this diffusion and mass transport between two particles during the sintering process. Then vapor phase transport and liquid phase sintering. So these are the various mechanisms of sintering. So here you can see this is the pores. Okay, so the powder metallurgy speciality of this powder metallurgy products are a porous nature. Okay, so here you can see these are the pores. Okay, these are the small pores you can see. So because of this porous nature of the powder metallurgy product, these pores can be filled with some oils or some liquid metal. So if the pores is filled with some oil or some other fluid, that is called impregnation. And another one is the infiltration. That is the pores are filled with a liquid metal, molten metal, that is called infiltration. So these are the two secondary operations, impregnation and infiltration. Then our question is So the question is, what are the advantages of powder metallurgy? That is the question. Yeah. So what are the advantages of powder metallurgy? Yeah. So here, these are the some of the advantages. So you can see. Okay. So here you can see 1, 2, 3, 4 eliminates or minimizes machining. You can check the number 4 eliminates or minimizes machining. Okay. So machining means different machining process like turning, milling, drilling, etc. So here after powder metallurgy you will get the finished product. Okay. So eliminates or minimizes machining. So further machining process is not required. Eliminates or machining process machining. That is the eliminates or minimizes the machining. This is one advantage. Then what about the surface finish and tolerance? Good surface finish and closer tolerances are obtained. Second point. Then complex shapes, suitable even for complex shapes. So two important points are in powder metallurgy. The two important points are one thing is the metal. We can convert this metal into molten metal. That is number one. Okay. Number two is we need a die. That is the two important thing. Okay. If we can create a molten metal, also we can create a die, then we can easily develop any complex shapes. Okay. That's why it's suitable even for complex shapes. Then another point is components of difficult to machine materials can be easily made. If any materials can be difficult to machine, like turning or milling like that, okay, we can create any components of difficult to machine materials can be easily made. Only one thing is you have to create the molten metal and you have to convert that metal into metal powder. Okay, then only you can create the product component. Okay, so any difficult to machine materials can be created. Any components can be easily made, okay, with the help of this powder metallurgy. Uniform chemical composition and purity can be ensured. So wide variety of materials like metals and alloys of miscible and immiscible systems, ceramics, refractory metals and composites can be used. Okay, then can be heat treated or plated if needed. Okay, we can do heat treatment, plating, etc. Can be heat treated or plated if needed. Okay, can be oil impregnated for functioning as self-lubricating bearing. So I already explained what is impregnation. So can be oil impregnated for functioning as self-lubricating bearings, energy conservation, and a high level of material utilization. So here the material utilization is high level of material utilization and energy conservation. Okay. Materials like sintered carbides, refractory metals, porous materials can be produced by powder metallurgy alone. Okay, cemented carbide, refractory metals, porous materials can be produced by powder metallurgy alone. Improved microstructure resulting in property improvements as well as materials with a novel microstructure. So these are the some advantages of powder metallurgy. Okay. Okay, so cemented carbide, refractory metals, porous materials can be produced by powder metallurgy alone. Then energy conservation and a high level of material utilization. Machining, what about the machining? Eliminates or minimizes machining. There is no need to do any machining process. Then surface finish, very good surface finish and tolerance, closer tolerances obtained. Then we can create any complex shapes. That's why suitable even for complex shapes. But make sure that you have to create the suitable die. Okay, so the any difficult to machine materials, components of difficult to machine materials can be easily made. Uniform chemical composition and purity can be ensured. Wide variety of materials like metals and alloys, okay, of miscible and immiscible systems, ceramics, refractory metals, composites can be used. Cost effective production of simple and complex shapes, can be heat treated or plated if needed. Okay, can be oil impregnated for functioning as self lubricating bearing. So these are the some of the advantages of powder metallurgy process. Okay, thank you.